Hi, alright, now I'm going to discuss about integration by parts, which involving the finite integral. So there is a, can you see, it define, there is a region from 1 to 2. So, okay, for these cases here, I'm going to tell you, you're going to apply integration by parts. So, as you learned in the previous lesson, that I tell you that we will integration by part, usually we will apply the formula of u dv, right? Equals to uv minus integrate v du, right? You can then usually we were choosing a u and a dv in helping us, so it's just like a product rule in the form of integration. Okay, so u and dv. So then the u you're choosing based on this techniques, right? Based on this idea. So you can choosing ln. For these cases, you have ln as a logarithm function and x squared as a polynomial function, right? According to here, LPET, this comes first. Number 1, number 2, number 3, number 4. So as compete between L and P, so ln comes first, right? Ln number 1. So ln x. So the remaining one, ln x have taken as u. So the remaining one, x squared dx, will be taken by dv. Alright, so now I can start as u, you differentiate, v, you integrate. So du dx, differentiate ln x, you have 1 over x. So your du will be 1 over x dx. And you integrate both sides. Integrate dv, you have v. Integrate x squared, you have x cubed over 3, right? So this is what the information that you need here for you to solve the problem. So now I'm going to apply this into my finite integral by using the technique of integration by parts. Alright, okay, the formula for evaluating will be uv, right? uv minus with integral v du. Okay, the proper way of writing evaluate integral by using techniques of integration by part will be this way. You see, uv, right? Your u will be ln x, right? U will be ln x, and your v will be x cubed over 3. X cubed over 3. As this is already integrate, right? There are no integral sign here, so you can directly put the value from 1 up to 2, right? 1 up to 2. As this is still integrating, so integrate from v du, right? V du. So v will be x cubed over 3. X cubed over 3, right? X cubed over 3. So du. So du will be 1 over x dx. 1 over x dx, right? So as this, you are still continue in integrating. It's still integrating from 1 up to 2. So you just put the value of 1 up to 2 here, right? So, and you can evaluate later, as this is ln x. So ln x, x to the power of 3 divided by 3 from 1 up to 2. And for this, you can take out the 103, right? Factor out the 103. So then you have integrated from 1 up to 2, x cubed over x. X cubed over x will be x to the power of 2, right? X power of 3 divided by x, you have x power of 2. So you have x power of 2 in the integral. So later, you can write ln x. Okay, you can rewrite this as x cubed ln x, x cubed ln x over 3, right? Over 3 minus with integrate x to the power of 2. X to the power of 2 will become x to the power of 3 over 3, right? X to the power of 3, adding 1 over with 3. 3 times 3, you have 9, right? So now you have you have complete integrated everything from 1 up to 2. So from 1 up to 2, as this one integrate, you also from 1 up to 2, right? Negative 1 over 9, 1 up to 2. So now you can evaluate this by substituting 2 first into the integral. So you have 8, right? 2 to the power of 3, 8 over 3. 8 over 3 ln 2, right? 8 over 3 ln 2 minus with 2 to the power of 3, 8 over 9, right? This is when the time 2 is substituting into the bracket, right? You have 8 over 3 ln 2 minus with 8 over 9. Now minus with 1, right? 1. So x cubed. So 1 cubed over with 3 ln 1. As you know, ln 1 is 0, right? Negative with 1 over 9. So finally, you have this one better. You just don't live in decimal form. If you can get the exact form, it's even better. 8 over 3 ln 2 minus with 8 over 9. 8 over 9. And this will turn to be 0 because you have ln 1 here, 0. So negative, negative, you have positive 1 over 9. So then you were getting 8 over 3 ln 2, 8 over 3 ln 2, minus plus 1, negative 8 plus 1. So you have negative 7 over 9, right? So this should be your answer for these cases here. So as integration by parts, you also can using calculator in evaluating. So let's see. Right, okay, let's try by using calculator. Okay, integrate as usual. You just key in the limits from 1 up to 2. 1 up to 2. So then the integrand will be alphabet x to the power of 2 ln alphabet x, right? So pressing equal, you have 1.700706, means the answer will be 1.071, right? So if you're using calculator and key in this thing, so you have 8 over 3 ln 2, you are still getting the same result. So minus with 7 over 9, so you are still getting 1.071, right? But this is a more exact value, right? This is more accurate before you round off. Okay, so let's go for the second examples. Alright, okay, let's look at this example. Okay, this is also apply integration by part because you can't see a function where it's a suitable means a suitable function of u to replacing any variable here. Alright, so as you see that x squared, and this is a linear sine 2x. So I'm going to apply integration by parts. So I'm going to introduce you another techniques if there is a definite integral for integration by parts, because as you know that these cases, this case during you watching the video for indefinite integral about integration by parts in my lesson in the previous video, so you know that this will be involving two integration by parts, right? So if you want to keep writing this for many times, so it will be very untidy, right? So what I'm going to do now is I'm going to ignore this for now first. All right, I know that it is a limit from pi over 6 to pi over 3, right? So but I assume that there are no limits. I do in an indefinite way. I do this in an indefinite way. So what I mean here will be I will apply integration by parts. So uv minus integrate v du, right? So as I need a u, as I need a dv. So according to this case here, ln, you don't have ln in this case here, log here, you don't have. So you have polynomial x squared, and if you don't have exponent, but you have sine 2x, right? Based on this number 2, this number 4, so this one should come first as your x squared, right? As your x to the power of 2. So followed by dv, this is your u, and this will be your dv, sine 2x dx. Alright, so I just do as usual without the limits there. So I differentiate, I getting 2x dx, right? 2x dx. As integrating this, you will have v integrate sine, you know that you are getting negative cos 2x over 2, right? So now this is the information that I'm going to use now. So I applying the integration by parts. So where uv, the formula, right, applying this formula, uv negative cos 2x divided by 2 minus with integrate v du, okay, v du, so it will be negative cos 2x over 2 multiply with du 2x dx. So as you can eliminate this, and you are getting negative x to the power of 2 cos 2x over with 2. Negative, you have positive, right? Positive, integrate x cos 2x. So now you have solved the problem for the first step where you have reduced the power of x power of 2 to x to the power of 1. So it means I still can't use any formula integrating this, so I have to apply integration by parts again for one more time. So where now my u will be x and my dv will be cos 2x dx. As the trigo part is always go for dv, right? So du will be dx. And integrating this both sides, so you will have sine 2x. Integrating cos, you are getting sine 2x over 2. Alright, so this is a second integration by parts that I'm going to apply now. So negative x power of 2 cos 2x divided by 2 plus with the formula uv, right? uv. So x sine 2x over 2 minus integrate v sine 2x over 2 v, right? du will be your dx. Alright, so let's do it carefully. So you have negative x power of 2 over 2 cos 2x, right? Cos 2x plus with x sine 2x over 2, and you have negative here, right? Negative. Integrating sine, you are getting negative again, so it will turn to be positive because integrating sine, you're getting negative cos, right? Negative cos will become positive and become cos 2x, right? Cos 2x divided by 2, right? Divide by 2, 2 and 2, you're getting 4 plus c, right? So this will be your answer when you're doing indefinite integral. Alright, okay. Now this is not what we want, right? As initially that the question is asking you to evaluate, right? Evaluate the integral of definite integral. So definite integral where is from pi over 6 up to pi over 3, right? But we are using the way of indefinite and solving this because we don't want to write the pi over 6, pi over 3 for many times, right? We can just write this way, and later, okay, we can using the answer here as the answer here, right? Negative x squared over 2 cos 2x plus with x sine 2x over with 2 plus with cos 2x over 4 plus c, right? We don't write plus c here because eventually that the plus c will be gone off because as you minus, right, plus c. So for the upper limit, you minus the lower limits. So the c and the c will cancel off. So there is no need to write a c here, right? Because this is definite integral. So we just ignore the c. And we're taking all the answer here, pi over 6 up to pi over 3. So this is the way that we want to evaluate now. So it have to be in radian form. You have to remember that if you're using calculator, you have to make sure you're calculating in radian form. So then you have to put the pi over 3 inside here. So negative pi over 3 square over 2 cos, be patient while doing this because 2 pi over 3, alright? So you have 2 pi over 3 plus with x sine 2 pi over 3 Okay, this one you will change to become pi over 3, right? Pi over 3 over 2 plus with cos 2x, right? So 2 pi over 3 also, 2 pi over 3 divided by 4. Okay, you have substituted pi over 3 into. Now you have to subtract. You have to subtract with pi over 6. Repeat the same thing. So you just copy down everything. Negative pi over 6 square over 2 with cos 2 pi over 6. 2 pi over 6. 2 times pi over 6, you're getting pi over 3, right? Plus with pi over 6 sine 2 pi over 6, which is also pi over 3, divided by 2 plus with cos 2 pi over 6, you are getting pi over 3 also, over with 4. Alright, now it's time for you to evaluate after you substitute. So then you have to using calculator in evaluating this. So key in everything this in your calculator, or I teach you another way. It will be, alright, you can actually evaluate the cos 2 pi over 3. You know that cos 2 pi over 3. Okay, let's be patient here. So, alright, you can key in this function. So if you don't want to substitute one by one, you can actually using this. You can key in everything here. So negative alphabet x square. So I show you that divided by 2, right? So cos 2x, sorry, 2 cos 2 alphabet x, make sure in radian form, plus with key in everything, okay, into the calculator. So alphabet x over with 2 multiply with sine 2x, and plus with cos 2 alphabet x, right, 2x over 4. So I have key in the function. For this function, I have key in everything. So I will getting right, x square. So I show you that I have already key in. So later I'm going to pressing the button calculate, right, CLC calculate. So let's calculate for the first part here. This is pi over 3, right? So pi over 3 means I'm going to calculate pi over 3. So I'm going to key in calculate pi over with, sorry, so shift pi here over 3. So I getting 1 point. I can just give in decimal form. So I give in 1.3 decimal places for more accurate. So 1.047, right? 1.047. So means that for the first part, you're getting 1.047 minus away. Okay, pi over 6. So to reduce my work, to rekey in everything, so I have already keyed in, right? So I just calculate pi over 6, right? Shift pi over 6. So equal, so I getting 0.524, 3 decimal, 0.524. So 0.524. So after evaluating, so I have 1.047 minus the 0.524, which gives me 0.523. All right, in decimal. So which were 3 decimal places, right? So this is my answer. So I'm going to recheck my answer by keying this. All right. All right. Okay. Just now I have miscalculated. Okay, I have made a mistake. So I have already key in, right? Key in everything here. The way I want to calculate the value of when the time pi over 3, right? Pi over 3. I just calculate. Is pi over 3. Shift pi, right? Shift pi over 3. You should press double equal and another equal. Then you were getting 0.603. Okay, 0.603. So 0.603. 0.603 minus away, so you calculate also, the correct way or using calculator will be pi over 3, pi over 6. You will key in pi over 6, so shift pi over 6. Okay, then pressing equal is not enough, you're pressing one more time, so you have 0.283, right? 0.283. So if you calculate, you are getting 0.603 minus 0.283. 283, so you're getting 0.32. Alright, 32. In 3 decimal places, after round off, you're getting 0.32. So that's a decimal. So you can also using the calculator directly calculate by using this, right? So you have integrate, so you can just key in, alright? So shift pi over with 6 to pi over 3, alright? Shift pi over 3. So you have pi over 6 to pi over 3, and alphabet x square sine 2 to alphabet x, right? So must make sure your calculator in radian mode, so then you have key in and exactly the same. You can directly get that answer, okay? So you can equal, pressing equal, you're getting 0.3194. This is more exact, but because just now I have already round off, so the answer, if you round off this, you are still getting the same. You are getting 0.32. Alright, I think that's all for this video.